All right, boys and girls, welcome back to the drive-through for the final edition of the drive-through of 2015. It's been a good year. Special shout out to all you sandwich lovers out there. Your sandwiches have inspired me to fatness and greatness, and it's much appreciated. All right, so here we are. Here's your Chapter 7 review for your exam. Some always, sometimes, never questions. The diagonals of a regular pentagon are all congruent. This is true for regular squares, regular quadrilaterals, and regular pentagons. This is always true. However, let me show you this. So notice that every diagonal in a pentagon skips two sides. So that one skips two sides. Or you could say it skipped three sides. But it's the same diagonal if you think about it. It skips, let's say, one angle, okay, one vertex. So that diagonal skips that vertex. This diagonal skips that vertex. This diagonal skips that vertex, and this diagonal skips that vertex. They are all the same. However, in a hexagon, just so you know, hexagon, what the hexagon? Okay, in a hexagon, the diagonals are not all the same. That's a terrible hexagon, I get it. But look, that diagonal skips one vertex, has one angle in between it. But this diagonal here is longer. It skips two, okay? So that's only true for quadrilaterals and pentagons, but it's always true for pentagons. All right, number 2. The measure of an interior angle of a hexagon is 120 degrees. That is sometimes. Read the question carefully. It doesn't say regular, so it's only sometimes true. Okay? An equiangular triangle is isosceles. What's the definition of isosceles? An isosceles triangle is a triangle with at least two congruent sides. An equiangular triangle is also equilateral. That has at least two sides. That is always true. An equiangular hexagon is equilateral. That is sometimes true. You could have a regular hexagon that looks a little something like this, where all your sides were the same and all your angles were the same. Or you could stretch that bad boy apart like he'd have a few too many sandwiches, and the angles would have not changed. But clearly two of the sides had, and that makes that sometimes. Okay, find the measure of angle D. This is a pretty classic type of problem. Let's see here. Let's copy that bad boy and paste it on the next page. Whoops. Okay, so we can call this angle X, and that makes that angle X. We can call that angle Y, and that makes that angle Y. I know that 2X plus 2Y plus 80 is equal to the sum of the angles in the big triangle ABC. Okay, well if I divide that, let's move to 80 first. 2X plus 2Y is 100, so X plus Y is 50, okay? Well, there you go. I also know that X plus Y plus D is equal to 180, but X plus Y is 50, so 50 plus D is 180, so D is 130, okay? All right, my last one. The measure of an interior angle is 6.5 times greater than an exterior angle. If this polygon is regular, what is the name? Okay, so 6.5 times the interior angle is equal to the exterior angle. Nope, that's not right. Let me read that again. Okay, the measure of an interior angle is 6.5 times that of an exterior angle. Now I have it right. An interior angle is n minus 2 times 180 divided by n, and an exterior angle is 360 over n. Well, that kind of works out nice. If I multiply both sides by n, that gets rid of the denominator. So now we have let's not skip anything. N minus 2 times 180 equals 6.5 times 360. So you get 180n minus 360 is equal to 2,340. 2,340. Okay, I'm going to write that over here. 180 times 360. So 64,000. So that's a minus sign. That makes me feel so much better. Let's try this again. Let's just rewrite it. 180n minus 360 is equal to 2340. Very dyslexic today. Add 360 to both sides, and you get 180n is equal to 2700. Divide each side by 180. 27 over 18 is 15. Seriously, what's wrong with me? So n is 15. So this is a pentadecagon. A pentadecagon. I got a joke for you. What did the hillbilly say that loves geometry when he went out his backyard after the tornado? Oh man, the decagon. What did Homer Simpson say after he walked out to his backyard after the tornado? Don't decagon. Boom!